Oh, I guess that's probably giving you both together. Welcome again to a streaming session today. We have a new mic. Probably can't even hear me over the audio. Let's turn that down. Let's turn this down a little. That's a little better. That music in the background was AC Alone, and it's called Lost Your Mind off his 2003 album. It's one of my favorite all-time songs. I love it. Actually, here, I'll show it to you on Spotify. Let me get this going. There, that's the... In case you want to look by cut, in case you're kind of a more visual person. Oh, by the way, let me know if the audio is coming through. I really would appreciate it since we got the new mic going. I tested, but you know, tests are nothing like production. So let me know if we got audio. All right, so that's the song. Let's move that out. Today's session, let's start by introducing the new microphone. Let me see. Oh, we don't need the desktop. We can go back to just me for this. I don't want to move the mic because it worked yesterday, and you know how. There it is. It's a Blue Yeti. It came with the boom arm. Whoop. And I got it at Best Buy. So Best Buy is one of the people that has responded well to the threat of Amazon in the sense that I can order from my computer, check to see if it's at the local store, and then usually it's within 15 minutes, they've already got it at the front desk. Pre-COVID-19, I would just walk right in and pick it up, show my card, and walk right out with it. Post-COVID-19, they'll actually bring it right outside to curbside and put it right in my trunk. So, and seeing as how things on Amazon seem to take about 3 years to get delivered now, I figured, given the poor audio quality last time, it was really important that I got a new mic. So again, I'm gonna actually put in the chat because nobody seems to be telling. Oh, voice is good, crystal clear sound. Thanks, Brian, for the coughing update. That's good to know. Good to know. Oh, I should turn off the music by now too. Let's see. I don't think there's anything else that I want to talk about now. I'll do more of the like TV shows I'm watching. I'm not a big TV person, but my fiance, Becklina, the queen of the universe, she really likes watching TV. It's her escape. Me, it's more video games. But so I've been watching some shows with her, and I have two that and critics disagree with one of my talks. One of the shows I like, but the other one that I haven't seen much, but I love the show. So we'll use that as a teaser to get you to stay to the end. Today I promised to talk about containers. So let's get started talking about containers. For those who know stuff about containers, you might be bored by the beginning. I still noticed even in this day and age when I go out and give talks, a lot of people may have heard of Docker, may have heard of containers, may have played a little bit, but don't get a lot about it, don't understand what it's actually doing under the hoods. And so this talk is talk. Can you tell I miss getting up on a stage and talking? Damn you, COVID-19! This talk is... Today I'm just mostly going to introduce containers and then show you them running on Postgres. I'm actually also going to be running this on Windows, and we'll see why in a little bit. This is... If you're really into containers and doing a lot with containers, I recommend either running a Linux VM or even just a Linux desktop or laptop or server or, spinning up something in the cloud that's Linux. And we'll explain why that's the case in a little later in the talk. Aya was super excited when she heard we were talking about containers, so she showed back up again. All right, so let's get started with containers. So I think everybody in this day and age knows about VMs. So I'm going to try to do a compare and contrast between containers and VMs. So let's get the full thing going. All right. So on the left, you can see this is what we're used to with VMs, right? You have your machine infrastructure, and it just means some sort of computer. It could be virtual, could be a real one, whatever, but it's just a computer. Then you put an operating system down. Then the VM has a hypervisor. And then when you install a VM, you install an entire operating system, and then the bins and the libraries that you need inside of that operating system. And then you install your app on top, right? And so each new VM is an entire new OS, right? You have to install the entire OS and all the bins and libs again. And then you have to and then you install it, right? And then you have to keep it updated and all that other stuff for each VM in particular. The other thing about hypervisors is usually if you say, hey, for the most part, if you say, hey, hypervisor, give this VM 4 gigs of RAM, it gets all 4 gigs of RAM off the host, from the host operating system, right? There are some ways for doing ballooning and a little bit of shared, but in general, when you give the VM CPU or RAM, it gets that CPU and RAM, right? It belongs to that VM now. So this is what we were seeing with a lot of the servers. You would go and you would tell your IT people, oh, I need a new server. I'm going to put some VMs on it. They're like, cool, that's going to save us money. But what ends up happening is a lot of developers and stuff would put a VM on, say, hey, can you provision me a VM? They'd get a VM. They'd get 4, 6, 8, 16 gigs of RAM because they're running some server process. They would never give the VM back, right? So that you could never reclaim memory. And soon enough, you've got 64 gigs of RAM in there, and then there's 4 people with 16 gigs of RAM each, and boop, you're done, right? That server's finished. And usually, not to cast aspersions on us as developers, but we tend to have very large eyes when it comes to how much resources we need versus how much we actually need. So we weren't really getting the infrastructure to actually burn white hot, right? When an IT person says, I bought this server, that's a sunk cost. And what they want to do is have that server run as hot as possible, meaning it's fully utilized, because they've already paid for it. So now they want to make sure they're getting their full use out of it. So if you have 4 VMs on it and it's running at 2% or 4% or 10% utilization, but yet you have to buy a new one, that's bad. That's bad purchasing, or I don't know, whatever you want to call it. But you know what I'm saying. So along comes containers. Now, I do want to say, now this is a big misconception that people think, and I want to clear this one up. One is people think that Docker and containers was new with Docker, right? Like that was some groundbreaking thing, and suddenly we had containers, and this was new just, I don't know, maybe it's like 6 years ago, something like that. And that is not true. So any of you old Solaris heads will remember Solaris zones. Those are containers. Linux has had LXC for a while, even before Docker. BSD had change root jails. These are all types of containers. And so containers have been around for a long time. What Docker did, so Docker, I think they were .cloud. They were some startup in the PaaS space, platform as a service. They were starting to go under, and they did this really nice pivot, which was to release their containerization technology. Like I was on OpenShift, and pre-Kubernetes, we had our own container technology as well. They open sourced theirs, and what was really nice about the Docker one was 2 things. One, it was basically agnostic to the Linux operating system. You could run it on Ubuntu, you could run it on Fedora, you could run it on CentOS, RHEL, SUSE. Any Linux operating system could basically run their container technology, which was nice because then it's not into this political turf war, it's above that. The other thing that they did really well, and we'll do this in a little bit, is they made a really nice specification for how you build a container and how you run it, right? And so it became very human readable. Before, it was like you had to know stuff about maybe SC Linux, you had to know how to write LXC, you had to know how to do all sorts of kernel stuff. And for the average user, that was not okay. But you'll see is the Docker file format was actually quite nice. So I think that's what helped it take off. I also think that containers benefited from VMs being around so much. When I was growing up as a dev, you always wanted your own server. I needed my own server. And when VMs came out, you're like, that's garbage stuff. I don't trust it. And then soon enough, VMs got good enough that people were like, oh yeah, I guess a VM's okay. And so once you can make the break from physical hardware, like a dev needing physical hardware of a certain size and a certain performance, to, oh, I'll take a VM, that's good enough. Then it becomes easier to accept the ideas of containers as well, right? Because now I'm no longer bound to the machine, I just need something on the machine. All right, so let's talk about what a container is. So again, here we have the infrastructure again, right? No difference. And then we have the operating system, so no difference, right? But what happens now is rather than putting down a hypervisor, you put the container engine on top. And this operating system here, the only real thing that's required for the container engine to run on top of it is a Linux kernel. And then what the container engine does is it makes, you can think of it like slices out of the Linux kernel, like it slices up the kernel and shares that Linux kernel among all this is the container right here, right? So among all these different containers, they're actually sharing from the Linux kernel on down, which the container engine provides to them, right? So right away you can see that you're not installing an entire OS, and you'll see this later when we talk about size of containers. You're not actually installing an operating system inside of a container. All that you're installing inside of the container is the bins and libraries on top of the kernel provided by the container engine. It's not exactly a kernel provided, but it lets the container think that it has its own kernel. But all you're doing is giving your own bins and libraries to make your app work, right? And so right away, we're not using whatever RAM is needed to run the OS. We're not using up space that's needed to run all the different pieces. Like in the hypervisor, each time we install the OS here, we're installing all the pieces that are need to run the OS, right? So you'd have like journal, if you're running a Linux systems, you have like journal D, system D, all the logging, all that other stuff that you would normally have to install with the OS. In the container, you don't need any of that because that's all from here on down, right? All you need are the bins and libraries and your bits that you want to run on top of it. So already we've got a savings there. Two, the other thing that you get that's nice here is, and this you kind of get this with VMs as well, is you get you can put different versions of the same container like I'm not saying it properly. Let me say it again. It's quite easy to run different versions of the same binary or package that you want to run. Let's say Postgres, because I said I would talk about Postgres today. You have your container. This could be Postgres 12. This could be Postgres 11. This could be Postgres 9.6, right? And they won't conflict on your operating system because these are all self-contained within themselves, right? So it's quite easy to have multiple versions of the same software on your OS. And so this is part of why it's awesome from a packaging perspective. But the other reason it's really awesome from a packaging perspective is when you put the bins and libs in there and your app, in general, what you do is you make your container ready to run so that when someone says Docker run, it just runs, right? And so when I was at the first DockerCon, I was the demo monkey for Brian Stevens, who was then the VP of product at Red Hat. And we were sitting in the green room, which is basically just some conference room in the center. And Dan Walsh, one of the guys who worked on SE Linux and helped put SE Linux into Red Hat Linux, was there. And he's like, I don't care about all this resource sharing and all this other stuff. He said, what I really am excited about is we can finally get away from shipping software as RPMs, right? And what he meant by that was, when I give you binaries and you put binaries down, so whether it's an RPM, whether it's a brew, when you brew install on Mac, or you do an MSI and you install on Windows, all those things, all you're doing is putting down the binaries. The person still has to figure out how to configure and run the software. And for most people, they don't really care about that configuration, at least certainly to get started. Right, and if you give them an easy way to overwrite the default configurations, they'd love that even more. But what we can do now is we can actually make it so that when I put Apache down on my machine, I just say container run, and I've got Apache running, and we'll do that later, right? And you can see how much better that is as opposed to, okay, first install this, then go to this file and do this, then do this, then do that. Like, there's a whole bunch of stuff you would have to usually do to get something running, and you can get away with that, and you can have multiple versions, right? So this is really big in the Postgres world, where it becomes quite difficult to have multiple versions of Postgres installed on the same machine. So you sometimes have to do this shuffle when you're trying to upgrade, or a client writes to you and says, oh, but this is a backup from 9.6, so you have to first import it into 9.6 and then move it. So you can't really do that. If you'd have to do different VMs right here, or you'd have to have different machines, and we can do it quite easily with containers, right? One important thing I think I should bring up at this point Oh, actually, is there any questions? Let me go back over to... I keep talking and I don't have my window up, so I can't see if people are asking questions. So I don't see any questions yet, but I also know there's a lag. So let me type it. I think that's what we'll try out. We'll see if that works. Any questions? Oh, and how loud is Aya's boat? Oh, how loud is Aya on the Antler? Should I take it away from her? Oh no, it's Hetty. Hetty. Sorry. Okay, no one's answering, so either nobody's there. Aya's fine. Okay. All right, so I guess I have no questions. All right. So one other thing that I want to say now then is containers don't contain in the sense from a security perspective. I think a lot of people say that, oh, well, I put stuff in containers, so security is taken care of. At this point in the evolution of containers, they are not, I mean, they do a little bit of help around security. It's better than nothing, but you do not look to containers to the most part as your security solution, right? I mean, hypervisors are definitely much more better for isolation. Because if I hack this OS, right, I actually have to be able to then hack the hypervisor to get into this OS. And hypervisors are a pretty small code base, so it's a much more secure solution if you need strong isolation. Containers, not as much. Don't rely on containers they're not like a strong security profile. So don't be that dev saying to the security people, oh, well, I put it in containers, so everything's secure now. Don't be that person. Right. Unless you're that person who knows actually that like you lock down your containers some with SC Linux. And even if you do all that stuff, a hypervisor is probably going to be a more secure solution than a container engine, right? Because this is actually sharing, there's the container engine. And then once you get into if you can hack the container engine, you can actually you've got access to the kernel, right? And we'll talk about some ways to mitigate stuff later when we actually show an example. Let's see. Oh, another thing is because we're sharing the kernel in here. So let's get back to resource consumption. When you start up a container, you can say, I want this container to have 4 gigs of RAM, let's say. And I want it to have half a CPU. That's all well and good. And the container engine will say, fine, I will try to guarantee that for you, but I'm not going to exclusively lock that by default for your container. So what that means is, we as the dev said, oh, I need 4 gigs of RAM. Yeah, if you're not using 4 gigs of RAM and you're only using 2, your container's only using 2, then that other 2 is still available to other things on the operating system because the kernel can actually do the memory management. There are ways to hard limit how much memory or CPU a container can get, right? The container engine can say, yeah, you're not getting more than 4. Like you said you wanted 4, and there's no way you're getting more than 4. So you can actually prevent them from doing an out-of-memory error for the entire OS, and it'll only use as much as it needs. So it's actually usually a much more efficient use of resources, and you can usually pack them much denser. On OpenShift, when we were using containers, we were getting we were over provisioning, right? Because most developers don't need as much as they think, and so you could over provision but we were doing over provisioning by about 50%. And everything was still running fine, right? And we were just getting really good utilization out of our resources. So that is the containers and a basic introduction to containers. Again, I'll see if there's any questions, just put them in the chat. If you see me flicking over there, that's me just looking to see if anybody wrote any questions. Let's see. Now that we've covered that, I've covered the history of containers. I've covered the lighter weight. I covered them solving the package problems because all you're including is the bins and the libs. Security concerns, right? One other thing though. And so this will come up later as well. This is the last bit before we start actually using them. The part that we're talking about here is when we talk about this operating system, for most containers that we're talking about right now, they expect there to be a Linux kernel here. Right? And so this is why when you're using Docker on Windows or Mac, it actually installs a VM. There's no way for normal Docker or any other container engine to use the Windows kernel to make a container. It's expecting a Linux kernel to be there. So Docker for Windows or Mac does is it installs a VM, a small little Linux VM, so that there is a Linux kernel there. And when you do commands on your Windows machine or your Mac, it's actually executing those commands inside of the VM rather than on your local machine. There are Windows containers, Windows native containers, and those are containers that expect a Windows kernel to be there for them. And those run on Windows machines, and Microsoft is leading that. I think you can actually now tell Docker. I'm not a big Docker user for the most part. I usually end up using, when I'm doing a lot of container work, I actually work on my Fedora machine, and I end up using Builda and Podman. And I can't show them because I can't get Hyper-V to spin up Fedora right now. But I can talk about them, and I'll show you some links for them in the show notes later. But in general, I use the Linux containers for the most part because I'm deploying to Linux servers. So, all right, let's move on now to actually, let's see, did I want anything else on here? There's a nice little page here from Red Hat about a lot of the stuff I talked about and the difference between them, right? And about container security, right? So, I think it's more interesting right now to go into actually doing some stuff with Linux containers. So I've already got, if you look down here, I've already got Docker running, right? Docker desktop. I'm going to do this on Windows because I assume most of you are running either Windows or Mac. Maybe a few of you are running Linux as your desktop machine, in which case this is all way, way easier, but that's not the case probably for most of you. All right. So I have a GitHub project. Let me show you. Do I have it here? Let's see. Oh yeah. No. Where's my? Oh, here's my. We're going to be working with this little repo here. It's the Steve 0. This is my GitHub, and it's called My Docker Images. And I built, a couple simple Docker images or Docker files that I use when I talk about this stuff. And so the first one we're going to do is just the most simplest one of all, right? And so it's called simple, and it's a Docker file. And it just runs Apache web server. I'm not up with all these cool kids with Nginx and all these other servers. Apache's good enough for most use cases, and I understand it, and I've used it a lot. So I'm going to walk you through now a Docker file. So this is what so that's a good thing to actually talk about while we do this. There is two pieces to what we usually call containers. There's the image, which is the compiled image of a container, right? So it's what we spin up when we spin up a container. So if you're an object-oriented person, at least in Java, there's a class, which is the abstract type, and then there's the object, the actual instantiation of that class, right? And that's the same thing. The image is what you spin up to make an actual running container. Right. And if you're an Amazon user or any of those cloud provider users, usually there's some sort of image. So in Amazon, that's an AMI. And then you spin it up, and then there's a running instance of that AMI. Right. So AMI is the same as the image. And when you're using Docker or Builda or any of those, you actually can have a file that says, here's how I want you to compile that image that we're going to use to spin up the container. And so in the case of Docker, it's a Docker file. And here's this, I'm going to go really basically through the syntax on the Docker file, and then we'll compile it and we'll use it. So what we're saying here is this from line says, is there another image that I want to use as the base image that I'm going to layer my stuff on top of? So an image has a layered file system, much like CDRs, for those of you who remember those shiny, spinny things that you could write to. It's a layered file system in that each of these steps that we're going to do here is going to actually add a layer to the file system. And once you've written a layer, you can't actually erase that layer, just like on a CDR, right? You can overwrite it, but it's still going to take up that space underneath. And so what we're going to start with is we're going to say, okay, for the base layer, grab the CentOS 7 image and build on top of that. And this is nice because I know that Red Hat will take care of this CentOS base layer. So every time I rebuild my image, it'll get all the fixes that are in any fixes that have happened in the CentOS base image, right? And this is not a complete operating system. This is just the pieces of the CentOS operating system that they think, the CentOS image maintainers think, would be important for anyone trying to build a container, right? So it doesn't include the kernel. It doesn't include journal D. It doesn't include system D. It doesn't include a whole bunch of other, it doesn't include the X windowing system. It doesn't include any of that stuff. It's about 200 megs of the binaries that the average container builder is going to really need, as like, these are the things almost everybody needs. So I think it has like wget in it. It has VI in it. It has bash in it. It has a bunch of stuff that's just like basic plumbing. And then we're going to go ahead and put stuff on top of it that we need to run Apache. But it doesn't include Apache by default. It doesn't include postfix. It doesn't include Postgres, right? You have to add that stuff. And so I want people to think like, oh, when it says from here, and it's using a base operating system, whether that's RHEL, CentOS, Fedora, SUSE, any of those, it's not an entire operating system. The next thing we're going to say is who's the maintainer. This is just some metadata. I should probably change that at this point, but that's when I wrote it. The next thing we're going to do is say run. So this is something that we want when we compile, we want the container compiler to run this command. So we're telling it to install. We don't want any docs. We don't want to get prompted for, are you sure you want to do this? Right? So no, don't prompt us. Don't install any docs. And then just install HTTPD. Right? That's all we're doing. If I was making this for production, I'd probably do an update first. And then I would install. And then and then what I'm doing here is at means don't finish this command line until you run this next thing. So this all becomes actually this whole thing is actually one command. So what I'm doing here is I'm saying clean all. So when we install RPMs, not only does it put binaries into the system, but it downloads the packages and puts those packages into some directory inside of the operating system where it's put the packages. Well, in the container itself, in the image and in the container itself, we don't need those packages anymore. We just needed the binaries. And so we don't want to take up space with these things that we don't need. And again, since we can't ever erase anything once we write it, we make sure we do this clean command as part of this don't finish. Like this says don't finish until you've cleaned out all those packages. Once you've cleaned out all the packages, then you can finish and write that layer to the image. All right. And then what we're going to do, so that's that. This is the most basic container we're going to do. Then we're going to say expose port 80, which means by default, I want people to know that port 80 on this machine is going to be exposed out to the world, which makes sense because we're running a web server, which usually runs on port 80. And then that gets compiled to a layer. And then the next, very teeny tiny layer, but then the next layer, or actually no space layer, the next one is what command should we run? And so all I'm running here is user bin Apache control, which is how you start Apache. And I say run it in the foreground, right? So in containers, the general idea, the way best practices suggest, you should have one and only one main process running in the container, right? I mean, Apache is going to then fork and set up a whole bunch of different containers processes underneath, but there's only one main process that runs the whole container, right? And you don't want daemons in the background. You don't want things running in the background, because if that main process dies, you want the container to die, right? So, and then what you're like, oh my gosh, wait, then Apache would be down, right? But what should be happening is however you're running this container should automatically notice that the container has gone away and restart that container, right? That's the practice you want to get into. And so you run things in the foreground, you write to standard out, you write to standard error, because those are usually drained. Those log statements are usually drained to somewhere else, right? You can write to other log places, but in general, you should be writing, especially as you start to move to Kubernetes and things like that, you should be writing to the terminal. All right. So if you have a question about what I've done so far, please ask. I hope that, so we're going to start with a CentOS 7 image. We're going to say I'm the maintainer. We're going to install, when we build this image, we're going to then install Apache and then clean out everything before we write that layer. We're going to expose port 80. And then we're going to say, when I say Docker run, that command is what it should run, right? It's what it's going to run when the container starts. and it's going to run it in the foreground. All right, so let's go ahead. So I'll show you that there's nothing running. I have no and I actually went through yesterday. I have no Docker images running as containers. There's no containers running, so that's Docker PS. Shows you which are running. I can also say Docker images. And so I have a couple Docker images on my machine. I already have the CentOS 7 one, right? So that's already there in my machine. There's also the latest. That's probably CentOS 8. And I've got a couple other I've been playing with. This one will be using this one later. So these are the images. Docker has an image cache on your machine. And so these are the images that are already brought down and are already on my machine. So we're going to go to cd git /my Docker images. Right? And then we're going to cd to simple. And so there's my Docker file. So I say Docker build. And if the file's called Docker file, if that's what your Docker file's named, and you don't have to type anything, you can just say Docker build. Right? Oh, let me know if the font's big enough. Actually, let me just make it some bigger. There we go. That's probably nicer. There we go. And let's do that. Okay. So let's go ahead and Docker build. Oh, it does want the Docker file. Oh, you just say the Docker file in the local directory. Okay, so that ran really quick because I've built this before, right? And so it just really did it quickly. I'm trying to think of, let me get rid of, you know what? Let me get rid of, I want you to see the whole process. So let me get rid of CentOS 7. So let's get rid of the Docker images, Docker RM, is it RM? Docker RM, is it Docker RM? Let's see. No, that's a container. What was it again? Docker delete? No, what? Anybody remember the command? I did it yesterday. Now I can't even remember. Well, when in doubt, thank you, Sindil, for being my memory there. That's what I talk about with pair programming. Docker RMI. So instead of RM, it's RMI image. And so we'll CentOS 7, right? So I think that should do it. Yeah. So now if we go back to Docker images, yeah, and let's actually get rid of CentOS latest too. Let's just get rid of all. Okay. So now if I look at Docker images, those are gone. So now if I do Docker build, so the first thing it's going to do is it's going to say, I'm going to download that image. Then it's actually put that layer in there. Then it ran the yum install. Then it's going to expose it. And then it did it all. So they built all this stuff. I don't know how to get rid of the cache. Sindil, do you know how to get rid of the cache? Because it's actually saying, oh, he already did all these things yesterday. Because I like testing things before I actually do them publicly. And so it says, oh, I've already got that step. I can't point at the screen, can I? It says, oh, this step right here, I already cached that because I did it yesterday and nothing's changed. So I'm just going to run it. Right? So it downloaded 7. And then it just basically said, oh, that's in cache, that's in cache, that's in cache. Just add them on top. So you don't get to see it. When we build the next one, you'll probably get to see it. Okay? Just trust me that it downloaded and did all those steps. So now if I do Docker images, you'll see there's none. And this is the one we just built. And I built it 2 days ago, right, when I was testing. The reason why it doesn't have a fancy name or a nice name like that is because I didn't tag it. Right? So if I wanted to actually tag this to give it the nice names and everything, there's a doc-t command that I can do to docker build --help, right? And so there should be the tag, right? And right here. So if we want to make it look nice, oh, nice, Sindil. Thanks for showing up. All right, Sindil comes through with how we can build it without the cache. But let me finish with the tag statement and then we'll rebuild it from scratch. The tag is how you actually give it those nice names. And if you notice, the format is the name of the image, and then the tag is the tag you give it. And if you don't supply a tag, it's going to assume that the tag is latest, right? For Joe Schmoes like myself, just building stuff, latest is fine. if you're actually packaging stuff up for other people to use, you probably want to have, you can have a latest tag, that's fine, so people know what's the most latest, but you also want to tag releases so that if people ever want to go back and get an exact image, they know exactly which one to get, because latest doesn't say anything except for latest, right? So we'll tag ours. So let's first do a rebuild. Oh, we'll do a rebuild with no cache and tag it at the same time. Wow, winning! All right, so here we go. So we're gonna say docker build dash no dash cache, right? And then we're gonna actually also say dash t, and then usually if you've pulled a Docker image before, you'll notice there's usually a namespace / tag / name namespace / name tag. So my namespace, which I own in Docker Hub, so I'm going to call it the Stevo HTTPD, and I'm going to tag it 0.1, right? And then I'm going to say go. And so there you go. So now now you can see it doing the CentOS 7. That's a very quick download. It's like less than 200 megs. And then it actually is doing now it's doing the pull for the Apache stuff. And now you can also see why we did -y, because we didn't want to have it prompt because there's no intervention. And then boop, it's done. Right? So that's actually now built an image. And that image, if we go to Docker images now, you can see there's the Stevo HTTP 0.1 and 10 seconds ago. Right? And the size of that image is 260 megs. That image now is like an AMI for those of you who use Amazon. It is immutable, right? There is no way I can go into that image and change a file without actually rebuilding the image. So this image ID is actually guaranteed to be unique for that image. So I can either refer to the image using this name pair and the tag, or I can actually use the image ID. And so why this is great for especially people who are into like security compliance and all those long processes where they have to go through this whole set of processes and tests and test suites and then deploy that to production, is what you can do is at the end of your long build and test process, you can say this was the image that came out of that test process, and it matches the exact same image ID that I'm running in production. So that's a guarantee that nobody has like actually messed with the base image. The other nice part about this is if something does go wrong inside your container for some reason, some gamma ray hits your disk and corrupts that running container, you can actually just start again from that image, and it's guaranteed to be the exact same image you had before, right? There's no need to say, okay, well now run this script, install these bits, run these scripts, change these settings, do this, and now we're back to the same state. It's just get rid of it and start it up again, right? If anything goes wrong. So that's really nice that way. All right. So now we've built an Apache container. Let's go ahead and run it. So the way we're going to run this is we're going to say docker run. All right, so it says run, and we're going to run it in the foreground. So I don't want it to run in the background. I'll show you how we can. When we build the next one, I'll run that one in the background. What we're going to do is we're going to run it, and then we're going to say I want to expose the port. I want to expose this on 8080. I want to expose it locally on port 8080 because the Windows firewall will block port 80. But I want to attach to port 80 in the running container, right? And then I want to say the Steve 0 / HTTPD. And then I have to give a tag because there's no latest, right? For that, if I don't, I can't assume that there's a latest here because there's not a latest here. So I have to say 0.1. Right? Then I run that. And that's actually coming from inside the container, saying, he's going to use this as the server name directive globally to suppress this, blah, 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 blah. It's a normal Apache message when you haven't actually set the server name in the conf file, right? And so then, now if I go to my local machine and I go to localhost 8080, there is Apache running off my local machine in a container, right? So the nice part now is, to walk this all the way to the end, what would be great about this is for developers, and you start thinking about this for Postgres, and we'll show this later, is that I as a developer don't have to understand how to install and run Apache. some Apache expert can make the Apache container, give it to me, and I just say docker run with the ports, docker Apache expert / HTTPD, whatever version I want to run of the container, and it's running in the optimal format, right? And the container maintainer may make several different ones, like a high memory container image and a low memory container image and a proxy container image. And depending on what I want, I just actually run that container and it's all good to go. I don't have to think about how to install it. It's not running somewhere on my local machine, right? On Windows machine, I haven't put anything into my registry. There's nothing, I haven't installed anything. All I installed was Docker, and now I've got Apache running, right? If any of you've ever tried to compile Apache from source, you'll know that's just misery, right? So this gets us around all of those problems. And if I wanted to, so if I had another terminal open, right? If I had a different version of Apache, let's increase the size font on this one too, right? So what I could also do, let's actually run this other one, right? This none. We're just going to use the image ID this time. So we're going to say docker run, and then we'll do port -p 8081 to port 80. And this is we're going to run this image, which is the one that the very first one we built without the tag, right? But if you want to use your brilliant imagination and think that this is Apache 2 versions prior because someone wrote something specific to that version, but I need to run it, right? And now that's running. And if I go here, and instead I'll open up in a new container, right? So this is a new container inside of Firefox, and I go localhost 8081, that's that other Apache that we're hitting against, right? And so that makes it really nice to have multiple versions, because back to this, I don't get into any binary conflicts, because this version of Apache has all the bins and libs it needs, and this other version of Apache has the bins and libs it needs, and they don't conflict with each other. So I'm sure any of you who've ever used a Linux machine have been like, oh, I want to use the latest version of this, like let's say Postgres. Well, it turns out that to run the latest version of Postgres on the same machine that you're running an older version of, or PostGIS, let's say, you need a different version of GIS. Well, having 2 versions of GIS and compiling them and getting that all in the paths correctly is a nightmare, right? And in this case, it's not, because the container contains it all and it has it, and I don't have to worry about them conflicting with each other. All right. So I want to do, I don't know if I want to build more or I just want to show you using the Postgres and PostGIS ones. We're already 45 minutes in, and I'm guessing people are starting to get a little bit overwhelmed. So, and it's hard because I can't see the audience. I can't see you folks, all you nice people hanging out in my stream. Show. Okay. I'll show it. See, that's why I can count on Brian. Timony will just come in and just say what he wants. Way to be an East Coaster. Way to be from Philadelphia, I mean. All right, so one of the other things is, remember I talked about security? So here's a Docker file where we're not going to, that other one, our Docker is actually, our container, we're actually running as root inside that container. And why that's a problem, and I think I can show that. So I can actually attach to a running container. Let me show you how to stop a container. We need to stop both of them. So now, let's increase the fonts on this. Bloop, bloop, bloop. Okay. Docker PS. You can see we have 2 containers running, right? This one's running the one I tagged. This one's running the one I didn't. Let's kill the one that's not running my named one. So we say Docker kill. This is the way you stop it. And in this case, you can either use the name, Sweet Mesdorf. I like Optimistic Newton. Or you can use the image. You can use the container ID, right? Because that's so the container is the actual running image. So we're going to kill that. And now if I go back to the prompt for that window, I've got my prompt back, right? We shut down that container. That's how you stop an image, right? And then you saw Docker RM to remove. So now if I wanted to get rid of that container, so if I do Docker PS-A, that shows all the ones that are running and the ones that are stopped. So this is the ones that we stopped. If we want to get rid of that container for good, we do Docker RM. and we get rid of that container. Not the image, the container. So once you start up a container, it doesn't go, and then you stop it, it doesn't go away. It's sitting there on disk. And this will become important for when I talk about some of the Postgres stuff later in a little bit. All right. All right. So now I'm going to actually Docker exec into, which means I'm going to run a command into that running container. So I'm going to attach to that container and run a command. I'm going to say Docker IT, which means give me an interactive terminal, basically, and attach to it. And I'm going to attach to, oh, it's Docker. Wait, oops, hit the wrong thing. Hold on. Docker exec IT into this container. So attach to that running container and run bash. And now I'm running bash inside that container. And so I'm actually into that running container. And then if I say, who am I? I'm root. And that's a problem. The reason why is if there's an exploit in Apache and I can get that root exploit, I've now got root in the container, which makes it really easy for me to get root into the container engine. And then, as you noticed, I can actually, by default, I can actually attach to privileged ports, which means that the Docker engine or the container engine is running as a privileged process, which means I've now got if I hack root in the container, which then hacks into the Docker engine, I've now got access to a privileged process running on that Linux box. So it's really, really important that when you make your containers, you make sure that they don't run as root, right? And so the way you do that is, it's quite easy. You just assign a different user. You say, when I run, is that big enough? Let me make it bigger there. When I run as user 1001, some random high number user. You don't want to start as one of the lower users, right? Those are all privileged. But so here, you're going to actually run as a higher user. All right. So the other thing that we've done in this one is, and this is actually the whole thing, is what I'm doing is I'm copying the conf file from this copy command. So everything up here is the same. I'm copying the conf file from this directory into the running container. I mean, into the image. Sorry. I'm copying it from this conf directory into the image when I make the image. So here is how I can actually make customizations and then copy and overwrite. As the expert on Apache, I can overwrite the conf that's installed by default when I run stuff, right? And so I add stuff here, and then actually now I'm actually moving some files, right? Changing some permissions, and that's how that runs. The last thing we can also do with the Docker images is I'm going to show you how, suppose I was a user and I wanted to actually give my own HTTP conf. That's nice that the expert set it up, but I want to do my own. What you do is you use something called volumes or mount points. And so what this does, right, is same thing as before, right? And so in this case, I'm actually saying, hey, you know what? Inside the running container, /var/www/html is actually a volume, which means it's blank by default, but the outside user can actually specify a place on the disk inside the machine where that they want to mount into the container at that location. And if you've ever used Apache before, you know this is where its content by default comes from, right? And so I'm not going to do it now because I'm assuming most people here are for Postgres and PostGIS. But when I run this, I can actually say a command that looks like this. All right, let me paste this into the window. So if I had built that one, you say volume, right? And then I could say users, kale, you could say my projects /HTML. And then you would mount that into var www/html. Right? And then whatever index.html or whatever files are in this place locally on my Windows machine would actually get mounted into the container, the running container, and be available there. And any changes I made on my local machine, like if I updated that index.html, that would automatically change inside of the running container. Right? So that's really nice in terms of working on web pages. Right? You can run an Apache, mount a local machine where you're doing all your work, and as soon as you make your change, you flip over and refresh the page, and the change is already there. Right? Except you're using the configuration there. It's not running Apache on your local machine. It's running it in a container on Linux, which will actually probably match how you're going to run it in production. So it's not this like gotcha, like, oh, well, that was a feature particular to running Apache on Windows. It's actually running it in the real spot. Okay. Any questions on that? No? All right. So now let's get to the part everybody probably came here for, especially if you're running new containers, about why containers is awesome for Postgres and PostGIS. So I often use this container from Crunchy, which is my employer, full disclosure. But if I go to Docker Hub, let's go to hub.docker.com, and we go to Crunchy Data, you'll see we have a whole bunch of containers. The one that I use most often is actually based off a different one inside of here. So there's Crunchy PostgreSQL, right? And so this is a full-featured Postgres with PostGIS and R. You know, the R programming language. You can write functions in it for Postgres, embedded into the container. It's all set up and ready to go. I don't use this one in general, though, because if we go to the documentation on this one, let's see, container suite, container specifications, PostgreSQL, right? If you look at this one is built to actually act in a much more, how should we say, like a server environment. It's built to run on Kubernetes, right? So, and it's built to do highly redundant stuff and backups and a whole bunch of stuff that most devs don't care about when they're deving or on a local machine. And so there's a bunch of required permissions that are set, and you can set a whole bunch of environment variables, and it's got a bunch of other volumes you can mount. Remember how I said you can mount volumes and overwrite stuff, right? So you can actually PG data and PG conf, right? There's a whole bunch of stuff that you can do with this one, and it was just too much. So we went about and built one that's easier, and it's called Postgres AppDev, right? And this one is intended just for use, and the only environment variable you have to pass in is just the password, right? So if you go to rather than the doc, if you actually go back to Docker Hub and you look at that image is usually for some reason on the second page. It's the one I'm going to run. It's the one that was in my repository before. Let's see, where is it? Here. So this one, I'll show you how simple it is to run Postgres. This is going to be running Postgres 12 with PostGIS 2.5. So I go here, go back to, let's actually kill all my running containers. Oh, I got to get out of this. There we go. You like my little do something thing? Let's see, Docker kill. I'll use the name this time because Optimistic Newton is fun. All right, so now let's go back to this window. All right, so we're gonna Docker. Oh, actually, I think I can copy and paste it. It would be even easier. We're just gonna give a password here, and then we're gonna run this image that's already there. So we're gonna say Docker run. We're passing an environment variable that says pass in PG password equals the word password. And then we're gonna start up this image, right? And so I go. And so now it's running in the foreground. And you can see it's doing a whole bunch of stuff. It's doing the normal PG init, starting up a database. It's actually creating extensions for fuzzy string match. Looks like Ogre FDW is not gonna work because we don't have that. It's making a database called MyDB. And it's making a user named random user 2w3. It's stopping the server and then starting it again. Right? So it's on the initialization and now it's starting it. So you're going to say, Stephen, why are you starting up Windows Desktop for Linux? or Windows subsystem for Linux? And the answer is because just getting the PSQL client on Windows is miserable. I really wish somebody would just make the PSQL binary for Windows. The only way to get PSQL for your Windows box, and we struggled with this, Kat, and I struggled with this a lot, is to basically install all of Postgres so you have the server daemon and everything running on your machine, but I don't need that. I just need the PSQL client. So all I'm doing here is I'm saying PSQL localhost, right? So I'm saying just like normal, I'm saying the user, what was that user? Rand user to W3. And then the database was called MyDB, right? And I think that should be it. Oh, man. Let's try 127. I wonder, oh no. And this is a relatively new, oh man. Oh, this must be Windows Subsystem for Linux 2. Because I redid my machine and I haven't used this part yet. This is the part I didn't test last night. I thought I did Windows Subsystem for Linux 1. But now I have to figure out, oh man. All right, well, let's go figure it out. Pair programming. Localhost IP WSL2. Yeah. You have to figure out yeah. Well, let's see if it 0000 works. Let's try that. I don't think that's going to work though. No. I have to find out this is not the right article. There it is. I think that's it. Yeah. See, I'm supposed to do this. No? Really? I have to determine the WSL IP. If config, and then look for the IP address to that ETH0. Ugh. I think I have to run that here. This is why I liked WSL1. You know what? That really annoys me. Let's get to the bottom. Oh, it's still not working? So then what do you... If I run ifconfig here, that's not the problem, right? Because I don't... Oh, maybe that is the problem, though. Let's try this. But I think that's going to connect to myself. Yeah, that's myself. Let's try this other one. I don't know why they had to go and mess this up. It was so nice before. You could just say localhost and it would just work. Okay, hold on one other second. Hyper-V. So this is what's actually running our Docker desktop VM. Settings. Management. No, I don't want that. I want the network on this. Cancel. I don't want a checkpoint. I want to know the... I want to know the actual IP address of the Docker machine, because that's what's the problem here. Let's see if this will tell it to me. Oh, there you can see about switching to Windows containers. No. No. Golly, come on. Just tell me what the... Oh, I can do this, but this is actually a security risk. Because then this is available to others outside. And I don't... Okay, let's try... We'll do it for now, just because I think this will make it easier. No, I don't actually want... No. That's just for the daemon. I don't want to use the WSL engine. Really annoying. I have to find out the IP address actually of this Docker desktop VM. And does anybody know on Windows how to do it? See, I don't see a network adapter. Here. What? It should already have a network adapter. Maybe they changed... Oh, maybe Docker Desktop is updated. Well, let me just try one other thing. Never mind. I'm going to give up for right now. What I was going to show you, because this is a pain in the butt now. What I'm going to show you, though, is how this is good for us as developers once you can actually connect. So let's kill that process because we don't actually want to... We can't use it that way. So we want to Docker kill this container. The agitated hawking. I feel the same way. Hawking. All right, so that's back, right? It's stopped here. The way we're probably going to want to start this container in the future is this way, right? With this command. Let me copy and paste this and show you what's going on. So this is the preferred way. So we're going to say Docker run -d. So -d means run in the background, like a daemon. I don't want to see all this stuff and lock up my terminal. Just run it in the background like I would a normal one. Port 54. Oh, that's why we couldn't connect. You guys, it had nothing to do with all that other stuff. I'm going to blame you, Syndeal. I don't really not going to blame Syndeal. But the reason why is because when we ran it before, we didn't make a port available. So the port wasn't mapped. So the port wasn't, I couldn't attach to the port. It's going to work this time. Watch this now. Learn from my mistakes, people. Learn from my mistakes. So now I'm saying, yeah, you know what? Take 543 from the container and expose it on localhost. Here's the name of the user, Groot. So the guy from Guardians of the Galaxy. That's going to be the username. Password is still password. I want you to call the database, instead of calling it MyDB, call it Workshop. And in this case, we're going to actually change that because I'm going to show you how this becomes a nice workflow for you. We're going to call this Project 1. Then I'm going to name this container. So rather than it being called agitated hawking or the container ID, I actually want to call this container PostgreSQL Project 1, right? And then start up that container that we had before. Okay? So the reason why we can do this is, watch, we do this, starts up, it's running in the background. I got my terminal back. Now this will work. And the user was Groot. And the database was named Project 1. The user is Groot. The host is localhost. There we go. And the password is password. See, now it works. I can't believe I spent all that time messing around with that when the simple problem... See, this is what happens when you say, oh, the bug's in the kernel. No, really, the bug was between the keyboard and the chair. All right, so now I'm actually in my database and I can do whatever I want. And I've got a project that's all set, and it's got, what is it, /x? No, /x? No, /x. How do you show extensions? Dash, list extensions. There. Oh, /dx. Let's do the plus on the end just to be fun. Yeah. So we've got HStore turned on. That's a lot. I actually don't want the plus. No, quit. Ugh. Look at all those functions we have in there. Quit. No. Let's just do /dx this time. There we go. So you can see we have PG routing installed. We have PostGIS. We have the Tiger geocoder, and we have topology all installed, and PLR, and stat statements, and HStore, and fuzzy string match. Right? So those are all things. So I didn't have to, for those of you who've tried sometimes to install PostGIS, and it's been a nightmare where you didn't have the right versions of stuff. And so what you can get is you can actually have all this stuff ready to go. So we've already got PostGIS 2.5.3 ready to go. So you say, oh, that's nice, Steve. That's pretty good. I understand why that's great. Well, here's the nice part. Let's do create table blah. And I think it's just, I don't remember the syntax. Never mind. I don't remember the syntax. We can create stuff and just frazzled from what happened before. So let's actually get out, right? What you can also do now, and this is what's really nice, is you can now make another, we'll call this one project 2, and the name is PGL project 2. We can't start it on port 5432 because that's already taken. We can start it on 5433 or something, but we can also just go in and kill PGSQL underscore project 1. Oops. Right, so now that container is no longer running. I can go back and start this container on 5432, project 2. And now I can again connect to it the same way I did before. Right. And it's got the same user. Oops, that's not going to work. Watch, because I called it project 2. So there we go. Right. And now I've got another instance running, and I can do stuff inside of there. And so what I can do is I can kill that one also. Okay, so now if I do docker ps-a, you can see I've got PGSQL project 1 and 2. Now let's say the client calls me up, or I'm switching tasks and I want to start working back on 1 again. I can just say docker run PGSQL project 1. Oh no, not docker run. Sorry, docker start. So that's saying take a container that's saved to disk and restart it again, and it's back. And so now that database is loaded up with all the data that was in it before. So if I had done a whole bunch of like shape to PGSQL or PSQL, or I had done other import statements and written functions and all that stuff is in there. A container is actually mutable. You can write stuff into a container and it'll persist between restarts of the container. If you delete that container, so if I do docker rm and I remove that container, then all that data goes away. I don't have to even map volumes to get that persistence, right? If you actually want to be able to delete the container and keep the data there, then what you would have to do is back over here, when you start up your PG data, right? Remember there was this, one of the things you could do is there was a volume mount for PG data. You could actually, when you start that container, say this PG data directory is actually this disk, local disk. And then if you delete the container, the data doesn't get deleted. The data is still there. You can actually restart the container or make a new container again from the image and mount that volume again, and it'll all be initialized and already there, right? And so that's the other thing that you can do with pgconf. So if you have a settings, like you're doing a lot of big data analysis and you want to give the container a lot of memory, and so therefore you want to change the conf file, you could have several different confs sitting somewhere, directories sitting somewhere, like one for big data, one for OLTP, one for a whole bunch of different things. And when you start up the container, you can say mount this path to my local my Postgres.conf into the conf for the running container, and it'll just get all those settings. And then next time you say Docker start, it'll mount and do all that stuff it said you told it to do the first time over and over again. So I haven't been doing it on this machine, but on my Linux machine, I've got 4 different containers that I use over and over again. Like one for our spatial project, one for learning to think in SQL, one for our demo data, and one for our Katacoda scenarios, right? Our learn.crunchydata.com. And I just start and stop them as I need them. And I have different versions. Like one of them is actually running Postgres 11, right? So I think that's actually really quite nice and useful for most people doing their work. One other thing that you can do is if you don't use a mount, when you can actually export a container, and if you export that container if you tag it and export it as a new image, if you didn't use a mount, if you just made the data inside the disk of the container, it'll actually export that data too, right? So as long as you didn't mount that directory, you can then tag and export the container as a new image, put that up into Docker Hub or put it up into your company's repo, and it'll actually have the data in there already, which is great if you're doing software development and you want to have a test image. Like here, just spin this up and it'll already have all the test data in it. And we'll all agree that the test data is the test data and we have to pass with that data. So I think I'm done for now, but I'm sure there's questions or things that people want me to talk about in another video. Again, sorry about the error between the desk and the keyboard. And then let's see what else. I think that's it for now. I'm going to stay on the last bit of this is I'm going to talk about the 2 TV shows. So if you don't care about the 2 TV shows I'm watching, you can dash. And if you're watching this on YouTube, you can dash now too. The 2 TV shows I'm really watching a lot now. Here, we're done with the screen. So we'll just go to this, just me now. The 2 TV shows are one, Westworld. So I watched the first 2 seasons and we're watching the 3rd season, and it's nothing like the first 2. I just like how it's kind of playing with this idea about what's a human and what's not a human. And I still like, the critics don't like the new season so much. I kind of like it. I mean, it's not like the first 2 seasons in that had like a kind of a coherent thing around this Old West scenario and the androids out. Now the androids I'll spoil it for you. Now the androids are out, but I still think it's a lot of fun. And it's like a science fiction. It's kind of like a Blade Runner now. It's a little bit more like Blade Runner. And it's kind of fun, and it's got some new people in it, and it still does that whole messing with your mind, like who's who and what's what. Not quite as much. I liked the messing with what's reality and what's not reality and timelines that it did in the Old West world. Okay, so that one's the more controversial one in terms of the critics. The show I really love, though, is Dave on Hulu. It's from Lil Dicky, the rapper. And it's a semi-autobiographical. It's like taking stuff that happened, some stuff that kind of happened in his life and didn't happen in his life, and just making a little sitcom. They're 20-minute episodes. Okay, so here's the reasons why I like it. One, it's funny. I think it's like the stuff is hilarious. But the other stuff I like is, one, he's got 3 other male friends, and it's showing male friendship on a sitcom in a way that I never experienced as a kid. Like, we never grew up with those images. Like, he's got one black friend. He's a white Jewish rapper. So, of course, I relate to him because he's like a white suburban Jewish boy. But he's got one black friend who he went to school with all his life, but who's also like a record producer. So he can talk street lingo, but he also talks, when he talks normally, he sounds like Dave, right? Like a suburban kid. So but they're like best friends, and it's really interesting when they talk to each other. Then he's got this like white finance friend who they like scrubs acne stuff on his back, and it's just the relation, like it's his housemate. And so like when he leaves the house, they say "I love you" to each other, but not in I love you like a sexual way, just I love you like showing affection between guys in a way that was never okay when I was a kid. And then he's got like a rap black friend who is like much more in the street, but like they're just all really good friends, and they all talk to each other really nicely. And like there's this one episode when he's having sexual problems with his girlfriend, and the way they just talk to each other was such a nice example of stuff we never get to see. So I love that about it. I love that he and his girlfriend had this really big fight about a really hard topic, but nobody freaked out. I mean, there was a little bit of drama, but then they also worked it out really well. They dealt with really uncomfortable topics around sex, but had the couple like deal with it and stay with it. It's just a really good show. I really like it. So check it out. I'm watching it through Hulu, but I think it's on FX. It's called Dave. Let me see. Dave show. Let's see. I'm just trying to give you stuff to watch during the, yeah, this is the show. So, oh, that's just the pictures. Of course it's, he's a rapper and he's like, here we go. This is the show. And it's really good. So, anyway, if you don't watch sexual things with your kids, don't watch it because there's a ton of sexual stuff in it. But, and it would be really uncomfortable to watch with your kids because it's uncomfortable sexualness stuff sometimes. But it's a really good show. Anyway, so there. And so I'm done for this week. I'm going to probably put out a tweet that asks for what people want me to cover in more shows. Maybe I'll start moving on to Kubernetes. Maybe I'll do more with the container when I now recognize my problem between the seat and the keyboard. Again, sorry about that. I and Hetty are definitely, they're done with the show. Thanks all, and we'll catch you later. Okay, bye.